Okay, so last night we looked at this problem about a square, and then an incredible thing happened after you went to bed. Our friend Suzanne von Oy made this amazing Desmos program. Okay?
Yeah.
Do you remember the problem?
Yeah.
Tell me about it.
So you had this square, which you didn't know its dimensions, and you had this kind of line cut through it, and line is 5 units long, and then the perimeter from this end of the black line, the long perimeter to the other, and this is 13.
Mm-hmm. And what was the question?
You wanted to see if this was enough information to figure out the dimensions.
Okay. Was it?
I don't think it was.
Okay,
Because
why not?
There were lots of different values, and with our the program of Mathematica, we couldn't figure the maximum out.
Okay. All right, so I want you to play with this and tell me what you see.
So start at the corner. So it seems like maybe when you go down, the square seems to get bigger, but then it's shrinking again.
Okay.
So that must mean, depending on where the 5 unit line is, it'll change the length of it'll change the dimensions. I think it will, maybe it'll be because, if you look at one side, so you have 2 complete sides here, and then you have one kind of almost complete side.
Mm-hmm.
So these 2 sides need to be smaller to make it 13.
Okay.
You have it, I think the maximum was around where these are equal.
Okay.
I think it'll be, these parts will be smaller, and the sides need to be larger to be 13 altogether.
Oh, interesting. Okay. Let's see if we can figure out there, if you leave that there, it's where you have equal sides. So you have an isosceles right triangle. Let's see if you can figure out the side lengths of that triangle.
So, use a squared plus b squared equals c squared. And if we have 2 times a squared equals 25.
Okay.
So that must mean 2a equals 5.
Okay, why do you think that? What did you do?
Well, because 5 squared is 25.
Okay.
So if you have 2a and you're squaring it, that has to equal 25.
Uh-huh.
So 2a has to equal 5 there.
Okay, there's a problem with that 2, though. So let's look at a simple example with a number that we can divide by 2. Suppose that that length was 4 instead of 5. So we would have 2a squared equals 16. What would a squared have to equal?
A squared has to equal this 8.
8, yeah, we can just divide by 2.
Yeah.
And so a then is the square root of 8. Is the square root of 8 an integer?
It's not.
Okay. But if we did 2a squared equals 16, and then we just did the square root and said 2a equals 4,
That's an integer.
that's an integer, and it would say a equals 2. But does that triangle work? Does a triangle whose sides that are 2 to 4, is that a right triangle?
No, because it would just be, I think, just a line. Because
Right, it would just be a line.
these two smaller sides equal 5.
Yeah, so when we have 2a squared equals 25, we first have to divide by 2. So a squared equals what?
12 and a half.
Okay, and then what does a equal?
The square root of 12 and a half.
Yeah, a equals the square root of 12 and a half. So in this case, the perimeter of the square is 13.
13.
Plus what?
The square root of 12 and a half. Times 2 here.
Yeah, so we do 13 plus the square root of 12 and a half plus the square root of 12 and a half. And we could look up, we could punch in a calculator what that equals. And it turns out it's just a little bit bigger than 20. And what did we see yesterday for what the maximum length of the square was?
We saw it was around 20 and a little bigger.
A little bigger, yeah. A little bigger. So that's actually what we found, and we were able to find it geometrically by looking and seeing that the maximum seemed to be when the side lengths were equal. And you had a good argument for why that's true. Good work, hon. Good job.